Hello students, welcome to the world of chemistry. This is Dr. Vikram Banchal and I'm dealing with thermodynamics for chemistry. And in this topic, this is lecture number 17. In this lecture, I will explain you what is isothermal expansion work for an ideal gas. Okay, what is ideal gas? So ideal gas is a gas which behaves ideally and it follows ideal gas equation PV is equal to nRT. That is known as ideal gas. Okay. Now in this case, I have to explain you with this experiment. Let us take the same experiment of argon, which is gas. Initial pressure is P1 and here volume is V1, which will be expanded to we have this one argon, pressure P2 and volume V2, and here condition is V2 is greater than V1 but P2 is less than P1. Okay, so one cylinder is taken in which we keep a gas. This is initial condition, piston is here and here we can have a gas inside this, and initial condition is P1 and V1. Okay, here we have initial state. Now the pressure which is applied by putting pebbles over here, and the pressure which is P1 is equivalent to P external or gas P. Okay, so here we consider this as ideal gas which is filled in this cylinder. So it is ideal gas expansion. In which kinetic energy will decrease and temperature also decreases. Okay, so if ideal gas expands reversibly, this is very important, reversibly. How will you carry reversible process? From volume V1 to volume V2 at constant temperature and pressure. Okay, and that will reduce pressure from P1 to P2. So the most important part is how will you carry reversible expansion. So the reversible expansion of the gas takes place in a finite number of small, we call them infinitesimally small intermediate steps. So in this infinitesimally small intermediate steps, what we are going to do? Very simple. We have to remove these pebbles one by one. Okay. So first of all, if you remove one pebble, there will be very small effect on this expansion of the gas. So initial state where the pressure of the gas is expected to equal to P external, and this is produced by putting pebbles on piston. Okay, if P external is decreased by an infinitesimal amount dP, the gas expands reversibly and the piston move through a distance dl. Okay, so how we can explain it? Let us see this. At present, this is the condition, and now because of the expansion of the gas, and this piston will reach here. Okay, and now the number of pebbles are less. So at present there are 10 pebbles. One of them was removed, and now we have only 9 pebbles over here, and therefore this piston moved upward. Okay, and the pressure will be decreased now. It could be P external minus dP, and this distance is known as dl. The distance traveled by the piston is dl. Okay, and now the earlier pressure was P external over here. Okay, at present in initial state the pressure was P external, that is P1, and now when piston reached to this new state, which is an intermediate state, this is again an intermediate, one of the intermediate state where the piston, this is because of removal of one pebble, and because of that now the pressure is P external minus dP. Okay, so this is the case. Since dP is very small, now we can say P external minus dP is almost equals to P external, because dP is very small. So we write is equal to P external. This is P gas or P1, or we can say P. Okay, so the work done by the gas in one infinitesimal small step, that is dW, which will be equal to P into A into dl, because this is the distance traveled and A is the cross sectional area of piston. So dW will be PdV, where dV is equal to increase in volume, small change in volume. Okay, that is why we write D. So increase in volume. Okay, so if there are so many intermediate steps, then the total amount of work done by the isothermal reversible expansion of the ideal gas from V1 to V2 is, look, now at the end the piston will reach here and this is the final state, and there may be few pebbles left over here in the final stage like this, okay, where volume will be V2, pressure is P2, okay. So volume final state pressure is P2, volume is V2, okay. So this can be explained with this formula. W is equal to integration V1 to V2 PdV. So according to ideal gas, for ideal gas, we know that P is equal to nRT upon V. So substitute this values in this equation. So W is equal to integration V1 V2. So nRT dV by V. Okay. Now W is equal to minus nRT integration V1 V2 dV by V, and the answer is W is equal to minus nRT ln V2 upon V1, or W is equal to minus 2.303 nRT log V2 upon V1. Okay, and you know that P1 V1 is equal to P2 V2. Therefore, P1 upon V1, P1 upon P2 is equal to V2 upon V1. So we have new formula, W is equal to minus 2.303 nRT log P1 upon P2. Okay, so any one of this formula can be used to find out work done. Either W is equal to minus 2.303 nRT log V2 upon V1, or W is equal to minus 2.303 nRT log V2 upon V1. So this way you can use any one of this formula to find out work done in reversible isothermal expansion of gas. That's it in this lecture. Thank you so much.